So next we come on to trig identities. So we go back to the unit circle. We know that sine theta is going to be y over hypotenuse, which is 1, so y over 1 is just y, so sine theta is y. Cos theta adjacent over hypotenuse x over 1 is just x. Now, if in this triangle we apply Pythagoras' theorem, we can see clearly that x squared plus y squared equals 1 squared, which is just a 1. So that means cos squared plus sine squared equals 1. And notice how I've written cos squared. We don't write it as cos theta squared, which effectively is, because you can end up thinking it's cos of theta squared. So when you're saying cos squared, you put the 2 after the cos, and then what you do it of comes after the power. So that's a really important trig identity. You need to make sure you memorise that. And from that, you can have two different versions by making cos squared and sine squared the subject. You could say cos squared theta is 1 minus sine squared theta, and equally sine squared theta is 1 minus cos squared theta. But if you learn that, these, can be found very easily from it. Secondly, if we look at tan theta is opposite over adjacent, and y is sine theta, x is cos theta. So we've got tan theta is sine theta over cos theta. Okay, that's a very important trig identity you need to remember. And all these hold for different angles as long as the angle's the same. So for example, I know that cos 70, cos squared 70 plus sine squared 70 is 1. As long as the angle's the same, it works. I know that sine 50 over cos 50 equals tan 50. Okay, right, so going on to example 6 then. Now, as I've just said, as long as the angles are the same, this identity will hold. So because I've got 3 theta, that's just simply equal to 1. That's it. Here, factorise 5 out. And 1 minus sine squared is cos squared. Here, this one, 1 minus sine squared is cos squared. 2 theta, the angle stays the same. Square root of cos squared, so you've got cos, square root, it just cancels. And sine over cos, if the angle's the same, is tan. Okay. Example 7, I need to prove this equals this. And be really careful with proofs because you know the answers. You need to make sure every single step is absolutely clear. Now this is why if you haven't seen it before, you're probably going to struggle to work out what the answer is or how to get from here to here. Also with proofs, if you don't know how to start, you can always go from the answer and work upwards, and hopefully that'll give you a clue what to do. Right, so this is actually an example of Excel's favourite thing in the whole world ever. It is difference to squares, because what we've got here is cos squared squared, and here you've got sine squared squared. So this is the same as cos squared theta plus sine squared theta times cos squared theta minus sine squared theta over cos squared theta. Now sine squared plus cos squared is 1, so forget about that because that bracket's 1, so 1 times that bracket. And now I'm going to split up this and divide each part separately. So it's cos squared theta over cos squared theta minus sine squared theta over cos squared theta. Well, cos squared over cos squared is 1, sine squared over cos squared is tan, or tan squared, which is what we needed to do. Example 8. There are a few ways to do example 8. I'm going to show you my preferred method, but there's a different method in the textbook, just so I'll show you that one in a second. First thing to do, just ignore the minus sign. So just draw any other right angle triangle, and cos is adjacent over hypotenuse. So this is adjacent, this is hypotenuse. Then you can use Pythagoras' theorem to work out the other side. Now, most of the time they're going to be Pythagorean triple, so it's 4. Or square, square, subtract, because you have the short side. Square, square, subtract, square root. 25 take 9 is 16, square root of 16 is 4. Now from that I can work out sine theta is opposite over hypotenuse 4/5. The problem with that is it could be plus or minus. Now the way to tell if it's plus or minus is that denotes a reflex angle. So on a sine graph, here is acute, here is obtuse, here is reflex. So you can see on a sine graph, when it's reflex between 180 and 360, the sine graph is always negative. It's always below the x-axis or theta axis. So it must be minus 4/5. You can do it using the trig identities, so we can simply say that if we want to find sine theta, we would say that sine squared theta is 1 minus cos squared theta. So sine squared theta is 1 minus 3/5 squared is 9/25. So that's going to be 16/25. And then square root sine theta is 4/5. And then you'd need to do the same thing to work out as minus. B. Sine theta is 2/5, that's opposite of the hypotenuse. So I need to use Pythagoras' theorem, so square, subtract square root. So 25, 4, subtract 21, so square root 21. So cos theta is adjacent of the hypotenuse. Again, I'm not sure if it's plus or minus, but we know theta's obtuse. So on a cosine graph, here it's obtuse between 180 and 90 and 180, so it's negative. Anytime a cos graph is obtuse, you know it's negative. So cos theta is minus root 21/5. Right, last one, let's say for 9. P is 3 cos theta, Q is 2 sin theta, show 4p squared plus 9q squared is 36. Well, what is 4p squared? To work out 4p squared, first you've got to square it. So p squared equals 9 cos squared theta. Just squaring both of them. So then 4p squared is going to be 36 cos squared theta. 9q squared, well, q squared is going to be 4 sine squared theta. 9q squared is going to be 36 sine squared theta. So add those two together, 4p squared plus 9q squared is going to be 36 cos squared theta plus 36 sine squared theta. Factorise 36 out. And then we know sine squared plus cos squared is 1. Okay, so then use the trig identities now to have a go at the questions on exercise 10C.